Hello, we are at checkpoint 4.7 from section 4.2, and in this checkpoint they want us to take the limit as x, y approaches 2, 1 of x minus 2, y minus 1 divided by x minus 2 squared plus y minus 1 squared. If we put in the values for 2, we're going to get 2 in for x, we're going to get 2 minus 2, that's 0, and 1 in for y, that's 0 again on top, 2 minus 2 squared plus 1 minus 1 squared. So this is going to be 0 divided by 0, which back in the old days when we only had one variable, we would say that's indeterminate. We can use Lapuz's rule, etc. So in this particular problem, they want us to show that the limit does not exist. Showing that the limit does exist for something like this would be a little bit more difficult, and we need to rely on the epsilon delta definition of a limit, which is going to be quite a bit of work. So I'm glad that they're asking us to find out that the limit doesn't exist, and they give us a problem where the limit does not exist. And let's take a look at this from a domain point of view. In our domain with x and y, the xy plane, this is the point that we're looking at. This is the point 2, 1. And what we want to do is we want to approach 2, 1 from a couple of different directions that will give us different limits. This is equivalent to limit from the left and limit from the right not being the same. And so if it's not the same, then the limit doesn't exist. But unfortunately, for something in 2 dimensions, we're not just coming from the left or right. We can come from the top, we can come from an angle, we can come from a curve going in there. So there's a lot of different paths to get there. So let's take a look at a couple of paths and see if they would give us different limits. Let's take the path going along the horizontal line, and with that horizontal line we're essentially saying that we're going to fix y to equal a 1 and approach that path. So let's do that. Let's say we're going to let y equal a 1, and then we're taking the limit. If you know that y is equal to 1, we're going to replace all the y's with 1s, and we're only going to have an x limit approaching 2. Alright, so y is going to be 1 and fixed. We have x minus 2, y is 1, x minus 2 squared plus 1 minus 1 squared. So this is actually going to give us the limit as x approaches 2 of, well, this is just going to be 0. And before we even take the limit, we're already going to get 0. So when y is equal to 1, our limit is going to be 0. Okay? That means on the surface, wherever the surface is, if we go along the y-axis, or if we go along the y equals 1, that's parallel to the x-axis, we're going to get a z-value of 0. Okay. Let's try letting x equal to 2 this time, with fixed value of 2 going in that way. Okay, what happens there? This is going to be limit as y approaches. Now x is going to be 2 fixed, and y is going to be the one that's changing, and that's going to approach 1. And then here we have 2 minus 2, well, that's going to be 0 already. And then y minus 1, 2 minus 2 squared in the bottom, plus y minus 1 squared. And again, before we even take the limit, this is already going to have a quantity of 0, which is going to be 0. So it looks like we're getting the same limit here, which is totally plausible. And it looks like there still might be a chance that the limit's going to exist. But, you know, they're saying that the limit does not exist. So the key to this is we're going to find another path going there. And the key to this path is that if you notice, the numerator was 0 before we even got this to be 0. So any of these horizontal or vertical paths going to 2, 1 isn't going to work. And so let's try another path, and this time let's take the path that's not going to be horizontal or vertical. And there's a lot of different lines to get there, but now let's draw a line that's not horizontal or vertical. And the easiest line to get there would be a line that goes through the origin, I think. If I look at this line, I see a slope of 1/2. So that's rise over run. So the rise is 1, the run is 2. And we'll write this as the line y equals 1/2 x. Now I can write y is equal to 1/2 x, or I can just switch it around and say x is equal to 2y. I think both of those would be the same thing. And just to avoid fractions, let's write x is equal to 2y as that same line that we're talking about. So now let's do that for our path. We'll let x equal to 2y, and what we'll do is we'll replace all the x's with 2y's. That means our limit is only going to be with respect to y. So we have a limit as y approaches, again, y goes to 1, and x is going to get replaced with 2y. So what do we have in the numerator? X is going to be 2y minus 2, y minus 1. The denominator is going to be 2y minus 2 quantity squared plus y minus 1 quantity squared. Alright, so let's find the limit of this. I'm going to be slightly unconventional and factor things out. Like for the first one, for the numerator, I will factor out a 2. So I have a y minus 1 times y minus 1. So let's just call that a y minus 1 squared for the numerator. For the denominator, I'm going to factor out a 2 from the first one, which is actually a 2 squared. So let's call that a 4 factored out, and then I have a y minus 1 squared plus y minus 1 squared. Alright, so that actually looks like it's going to be, so I factored out a 2 squared, that's a 4, and then there's y minus 1 squared here. There's 4 of them here, and there's 1 of them here, so that's 5 of them. So let's write this as a limit as y approaches 1 of 2y minus 1 quantity squared divided by, and now I have a 5y minus 1 quantity squared. And clearly those can get simplified, and before we even take the limit, we get a value of 2/5. Now the value 2/5 isn't really all that significant. What is important is that this is not equal to the other 2 limits that we found, not equal to 0. So what we say here is that we have paths that go to the point 2, 1. We got 2 paths that went to 0, but we have this one path that did not go to 0. So that one path that does not go to 0 says that now the limit does not exist. So that's our conclusion. Limit does not exist. D and E, because we have two different values for the limit. Okay, so this is how we would show that a limit doesn't exist. Hope that helps.